Okay, so doing these calculations by hand is kind of tedious. So what I'm going to look at here is how we would how we would tell the calculator to find the least square line without having to do those big ugly formulas. We still have to tell the calculator all of the points that it's going to be dealing with. And so in this video, we'll be looking at how to do this on the TI-83. So what we're going to be doing is you're going to press this button, Stat. It's for statistics. And in Edit, there's three different kind of tabs up here. You can see if I press the left and right arrow, it shifts between those tabs at the top of that screen. I'm going to want, in the Edit tab, I want the Edit option. Now I'll just hit Enter there. And what this gives me is L1 and L2. And, well, it gives me L3 there. Actually, there's more than that. If I was to scoot over, you can see it keeps going to L4. We're only going to be using 2 of these lists, though, at any given time in this class. And what I'm going to be doing is I'm going to be putting X coordinates in L1, and I'm going to be putting Y coordinates in L2. So let me go ahead and do that now. So 10. And what I'm doing here after I'm entering these, I just hit 20 for 20 and then enter, and you can see it brings me down to the next one. So I did 10, then 20, and I'll just go ahead and finish the rest of these ones off. Alright, there we go. Now I can press the up arrow on here to go to a previous one if I made a mistake or something like that, if I need to change it. If I need to change it to 35, I can actually just type over what's already there. You can see now it says 35. I actually want it to be 30, so I'm going to leave it the way it is. Alright, if I want to go to L2, I'll just press the right arrow, and I'll do the same thing here, 84.4, press enter, and it you can see it keeps these, it'll keep them side by side, so 10, 84.4. You do need to make sure that they are lined up like this, because this is going to represent the X coordinate of a point, and that is the Y coordinate. So you need to keep them in the same order. So I'll be right back after I get the rest of these Y coordinates entered. Alright, so I have all my Y coordinates entered. Now, you're going to want to quit back out to your home screen. So I clicked on second, and there's this little up arrow in the right hand corner that says that my calculator's whatever it's going to do right now, it's going to be using one of these yellow values. So if I was to press this button, it would do alpha lock. If I did this button, it would go into the test menu. What I want to actually do is I want to quit, so I'm going to press this button. And that quit me out of the stats. Now it's still saved in there. If I was to go back in here and press stat and edit, you can see all those values are still saved in here. So this is really, you can think of that as a separate screen. It's actually saving the values in the calculator. Alright, now I want to run the linear regression, is what it's called. And this is how we do the least square line. It's called the linear regression. It's back in the stat area, but instead of staying in the edit tab here, I'm going to go over to the calc tab. And I want the linear regression. On my calculator, it's option 4. There are other regressions that are possible, a quadratic regression, a cubic, a quartic regression. What these would do is they would give you, instead of a line that fits the data, they would do a parabola that fits the data, or a cubic that's, kind of does a swirly line, or a quartic. These are just different, you could do as high of a regression there as, well, it's possible to do, just not with this calculator. There's another linear regression. The difference between these is this one does ax plus b, this one is a plus bx. So you'll notice this one, your slope will be in a, stored in the value a. Your y-intercept would be stored in the value b. That's the one I recommend you use, because b is, we traditionally use b for the y-intercept already. This one, a plus bx, your slope would be stored in b, and your y-intercept would be stored in a. That one's a little weird. I don't recommend that one, but it does still work. This one right here is a linear, not a linear, it's a logarithmic regression. This one, we're not going to be using at all. Actually, we're not going to be using any of these other regressions. I'm just showing that they're here. There's a exponential regression, a power regression, logistic curve, and a sine wave regression. So there's all sorts of different regressions that your calculator can do. We're barely scratching the surface. We're only going to be using the linear regression, this one right here. Now, when I press enter, it just pastes this to the screen. Yours might very well give you a separate screen when you pressed enter there, and it would be asking you for what is it, X list and Y list. This is asking you where are the X coordinates of your points and where are the Y coordinates of your points. It should default to having L1 be your X list and L2 be your Y list. And so you should be able to just leave that exactly as it is and say paste, and that would give you get you back to this screen or something very similar to it. I'll hit enter again, and it'll tell the calculator to actually compute what's going on there. So it says linear regression. It says my A and my B. You can see those are essentially the same answers I got when I was doing this before by hand. Not quite exactly the same though. The 5596, you can see that actually came out the same. I guess I must have rounded incorrectly. It should have been 5597 is what I wrote there. But in any case, on this one, the 90.3, I had rounded when I put in the 0.5596. I had already rounded, and so that error, the error that I accumulated in rounding, actually was plugged into this answer. So there's a little bit of error in this answer. Whatever I got out of there, it was most likely, well, it is less accurate than what the calculator did here. Now the calculator still rounds, but it goes out to, I don't know, like 10 decimal places before it does any rounding. So it tries to keep things as accurate as it can, but just the limitations of the calculator, it has to store all of those individual digits, and so you know, the designers of the calculator made a choice. We're going to do 10 or 11 or however many decimal places of accuracy and then cut it off there. So whatever the calculator shows here is probably more accurate. Now what you'll notice is missing is the correlation coefficient. So let me show you how to, if your calculator does not show r and r squared on here, then you'll want to do this next stuff. If your calculator does already show r and r squared, you can kind of just read off what those are. R is your correlation coefficient. R squared is, well, just it's literally r, and you square the value. So you can read those off. But if your calculator does not show those values, like mine right now, what you're going to need to do, this is a one-time thing, unless you reset your calculator, you're not going to have to redo this. You can see above the 0 in yellow, it says catalog. So what I'm going to do is I'm going to press second and go to catalog. This is a list of all the various functions that the calculator has, and I'm going to scroll down for a little while until I get to one that says diagnostic on. And I'm going to press enter. And so when you press enter, you'll notice it just pastes it on your home screen. I need to press enter again to actually tell it to run that program. And what this does is it changes some settings in the calculator so that now when you run your linear regression, it's actually going to show you what r and r squared are. So I'm going to run that linear regression again. I'm going to say stat over to calc. I want the linear regression, which is number 4 on here. Press enter. And now when it does it, you can see I get r squared and r. I still have the same a, the same b, but now I get r squared, which is 0.92, and r, which is negative 0.96. So that's not really a surprise that r is negative, because the slope, the line that I said modeled the data up here, has a negative slope. And so it makes sense that r is going to be a negative value. It also makes sense that it's fairly close to -1 and r squared is close to +1, because I feel like this is a fairly, it describes the data fairly well. This point right here is really the only one that kind of seems like it's off of the chart a little bit. The rest of them fall fairly close, and you can see this is, I would describe this as a fairly good fit for the data.